Hello everyone! You are on the 3D Boost channel, and today we will continue talking about how to convert 2D concepts into 3D, creating game-ready or almost game-ready models. In this in the first video on this topic, I already showed the general process. In this short video, I'll be talking more, and in the background you will see my process of preparing 5 shields for submission to stock sites. This didn't take much time compared to creating them from scratch. Now I've imported all my models from Charlize to Blender via GLTF files, and I'm starting to refine them. One of the shields has a nice handle, so I'm going to separate it and use it on all the other shields in one form another. I want to point out again that this method is very convenient to game development. It allows you to create low poly models in a short amount of time. This is the handle I'm talking about. Of course, if you are making a stylized game, models created in this way may be overly detailed. However, I see this method as a quick way to get a model with textures, even if it's not perfectly optimized. This approach is great for creating working prototypes or even MVP products that can be presented to investors, managers, or teams. You can create nearly low poly models that are 2 to 3 times denser than the final mesh, but they are produced much faster. It's like a draft, but already colorful and detailed. On the screen I'm preparing the first shield. I've exported it to ZBrush and I proceed with the high poly, and then I apply Decimate to reduce the poly count for the low poly model. As I mentioned in the first video, I think ZBrush is better for this than Blender because it preserves the shape of the model better. I'm talking about decimation. I did the same process with the handle of the shield also. Okay, I separate the handle and I'm baking this in Marmoset, the first shield. In Marmoset I'm baking albedo or base color and normal maps from high poly to low poly. As a result, my low poly model gets color from Trellis and the normals from the high poly model that I quickly set up in ZBrush. Okay, now I'm make some improvements with handle. Unwrapping is automatic. I works with Rhythm UV, but for example for this handle, for low poly handle, I made the cut manually. It's because it's a simple model. Continuing on, I want to note that this process is convenient for quickly converting 2D concepts into 3D. However, after exporting from Trellis, models can have 40 or maybe 60, 80,000 polygons, which is too much for a prototype or MVP for presentation. But after applying Decimate in ZBrush, the polygons reduce to around 5,000, and it keeps the textures and normals, making the model suitable for use in game engines. Of course, when we're using Decimate, the mesh and UV unwrapping are not optimized, but we get textured objects that are ready for use in development. Now on screen I'm working on the second shield using the same method. Sometimes I manually cut the model to avoid stretching the UV. I'm using smooth brush, high polish brush, and I'm making some improvements on my high polish shield. Okay, now I'm also make a UV. As I mentioned, sometimes I need to make some seams manually, but often I use it just after unwrapping. Okay. And also I need to export the texture embedded in the GLTF file. And I do this in Blender, so I can use it in Marmoset for baking. Okay, right now I'm working on the third shield, and the process is 10 or 15 times faster, but it's the same. After unwrapping, high poly, low poly, after unwrapping on the Decimate model, export to Marmoset toolbar, and baking base color from Trellis and normals from ZBrush. Okay, this is a third shield, and the last handles for third shield, and the last fourth shield, because I already have fifth shield in from my first one video. Okay, and then like in previous video, I use stable projectors. It's a very convenient tool in this pipeline, helping to quickly bring the texture to a presentable state. Of course, there are artifacts, but for prototyping and fast development it's convenient. Moreover, this is convenient for texture artists. The artist who will later create the final texture for this project will not only get the low poly model from the 3D artist, but also the base texture from Trellis, which they can use to further refine the texture. These models were created for submission to 3D stock sites. I'm curious to see how they perform in sales. If anything sells, I'll share the results. Overall, in a short time I made 5 shields, though not with the perfect topology and textures. However, if you look at the CG Trader, for example, you will see many assets being sold at high prices despite not being perfectly optimized. In stable projectors, I use two approaches: color mode and non-color mode. In color mode you can paint directly on the texture, like in Blender or 3D Code, and save the change. Also, based on this color, you can then regenerate the texture using neural networks, like Stable Diffusion via the automatic 1111 IP. In non-color mode, in painting is used and the neural network will fill missing parts, like this. It's in paint mode with non-color mode. Okay, this is a fourth shield, and this is a first shield. Some improvements, some recalculation with Stable Diffusion, non-color mode, in paint mode, and so on. It's also pretty fast. Next, I quickly set up a render for previewing the shields on the stock sites. I don't even adjust the lighting, just I use the emission input in the shader to make the shields brighter in the render. Okay, I'm doing some renders with emission. It's good for me. Only one camera, and I'm rendering with PNG with alpha channel. After that, I export the renders in PNG and create a small collage in Photoshop, placing the 5 renders with a slight border so they are clearly visible separately. I'm using layer effects to add some outline and some shadow. Naturally, there is no high-level artistry here. I'm just doing this in test mode very quickly. It took me maybe half a day, even less, about 3 hours maybe. Okay, I arranged them and some background, add some background to make it look a bit more interesting. Maybe some gradient, like this. I plan to upload them to CGTrader and the Unity Asset Store. I could also post them on TurboSquid or somewhere else. Next, in Unity, I set up regular materials, apply the textures, I export it from stable projectors, and normal maps. As I mentioned, I create the normal maps after baking in Marmoset from high poly to low poly. Okay, I'm created a demo scene and place my shields in it. This is required by the Unity Asset Store. I also installed a plugin through the project manager called Asset Store Validator. It checks if everything in my scene is good. In this case, it tells me I need to create prefabs for my shields. I also noticed that my shields have incorrect scale and rotations due to the export from Blender. I changed the export preset in Blender and reloaded my shields. This way I got 5 shields. I make them into prefabs as required by Asset Store Validator, and after that, and after validation, all is good, and I now can upload the package to the Asset Store. So today you watched and listened to my thoughts on how convenient it's to use such a pipeline for quickly developing very low polygonal objects. It's great for quickly creating objects for your prototype and MVPs with a relatively low poly mesh compared to using pure 2D and 3D algorithms. You were on the 3D Boost channel. Like, subscribe, and see you in the next videos or shots.